Here is an example. In this example, he's asking us to find the Thevenin equivalent circuit. So Thevenin theorem is nothing but all you need to do is convert this big circuit into a simple circuit which has voltage source. That source voltage is Thevenin, and the resistance of equivalent resistance of that circuit in series with the voltage source. This is Thevenin equivalent circuit. So our goal is convert this big circuit into the small circuit with the voltage source in series with resistor. So we need to find Thevenin and Thevenin. So in step 1, we're going to find Thevenin, which is VAB in this case. So Thevenin is nothing but VAB, which is VA minus VB. I'm going to ground VB, take that as a reference. So all I need to find VA. VA is right here. So my goal is finding VA, to find Thevenin. Now to find VA, I know this current 20 I0 is passing through this. So let me see. Okay, so this 20 I0 is going over this. So the current passing through this is 20 I0. Can I say my VA is nothing but negative 2K times 20 I0? Why I'm taking negative? Because current is going in the opposite direction. So this is plus and this is minus. Since current is entering here, this terminal is going to be plus terminal, the other terminal is going to be minus terminal. So now I need to find I0. What is I0? I0 equal to 12 divided by 3K, which is nothing but 4 milliampere. So now my VA equal to minus 2K times 20 times 4 milli. So kilo and milli get cancelled. I will end up with minus 160 volt. That's my VA. So my VTH equal to minus 160 volt. Now the next step is finding Thevenin. So find Thevenin. Thevenin is nothing but Thevenin equivalent circuit between AB terminals. So I'm finding Thevenin equivalent circuit between AB terminals. To find, while finding RAB or Thevenin, so in this case Thevenin is nothing but RAB, replace all independent sources with their internal resistance. Replace all internal sources with their replace all independent sources with their internal resistance. Okay, so what is the internal resistance of a voltage source? So if it is a V source, short circuit, because internal resistance of a voltage source is 0. And if it is a current source, so it's a voltage source, it's a current source. If it is a current source, source will have or current source has infinite internal resistance. Replace it with open circuit. Okay, now if you have a dependent source, if there is a dependent source, the dependent source, keep it as it is and connect a 1 ampere source between AB terminals. You can use either 1 ampere or 10 ampere or 50 volt or 100 volt or 1 volt, doesn't matter. I always go with 1 ampere, it's easy for me. Connect a 1 ampere source between AB terminals to find RAB. Okay, why am I connecting 1 ampere source? Because the dependent source also contribute some internal resistance to the circuit, so I have to include that here. Now while finding RAB, my circuit, so here I have voltage source and here I have dependent source 20 I0. Here is my I0, I believe that's 3K, and here I have 2 kilo ohm. Now I'm going to connect to 1 ampere source. Okay, now my goal is still I'm going to find RAB equal to, I'm going to put VAB over 1 ampere. So that's my A, this is my B, I'm going to ground this. So all I need to find VA over 1 ampere to find RAB. Okay, now what is I0 in this case? Since there is no source connected to 3 kilo ohm resistor, so for sure my I0 equal to 0. I0 equal to 0 ampere. So this current, it's not producing any current at all. That means the current going through here is 0 ampere. Okay, so whatever the 1 ampere is going to go over 2 kilo ohm, right? So can I say my VAB equal to VA minus VB over 1 ampere? I'm sorry, VAB equal to VA minus VB. Can I say this as 2 kilo times 1 ampere? So it's a 2k volt. Once I have 2k volts, RAB must be VA over 1 ampere, which is 2k over 1, which is 2 kilo ohms. That's my RAB, resistance between AB terminals. Okay, now the last step, I have VAB and RAB. My VAB equal to, hold on, VAB equal to minus 160. So final step is I have plus and minus V Thevenin. I have this as a minus 160 volt, and R Thevenin 2 kilo ohm. Here is my A terminal and B terminal. I can read this as this is minus plus 160 volt. So basically B has higher potential than A. That's all it is, 2 kilo ohm. This is the equivalent circuit, Thevenin equivalent circuit of this given big circuit. Thank you.